coordinate and move everything because everything has a certain width and a certain height or a certain X and Y value. I'm going to call it width and height. You can call it anything you want. It doesn't matter, right? But essentially the coordinates is how the Cartesian plane is how Pygame normally runs. And what you have is that, you can move around the coordinate plane by changing the width and height of the object. And as you can see, and if you remember, there are many different objects. There are one objects which are the enemies, and we're going to call them aliens, which are the boxes. And we're going to have that little box down here, which is going to be our spaceship. And we're also going to have what's called a bullet. And the bullet is going to shoot up, right, towards our enemies, right? So before we even start the game, we need to think about, what we're doing and how we're going to do it. And also, these square guys are going to start going down. This can move left and right, but it cannot move up. And this thing just goes up towards the top of the screen. And we're also going to talk about how it disappears or how it disappears when it hits something, right? So that's essentially, the game that we're going to make. And now we're going to start making. I just want to show you exactly how everything works. And then we're also going to go through the game loop together. So yeah. Also, yeah, I should actually do one more thing, which is the what are class and objects. I'm just going to do a quick introduction. This is 5 minutes. Don't worry. I'm not going to take up too long the coding time. But what this is, what class and objects are, is that it's a different way to represent things. You've probably learned Python the functional way, right? Albert probably taught you what are functions, right? Like let's say def function, and then you have different things in it, and then you do different things. This is called, functional programming in Python. And what this is that you represent anything you want to do. Let's say you're making game, or you're making, I don't know, anything, or even like a simple program. You're representing it what you want to do, right? Let's say you want to pick up something, then you would have a function called pick up. If you want to add something, you would have a function called add. So you're breaking a complex thing down into things that you have to do, kind of like a robot does, right? It moves forward, picks an object, and then moves back and brings it to you, right? It does simple commands. It's or object-oriented programming is different in the way that it doesn't really work in the sense of it doesn't work functionally. It doesn't care about what you do. What it cares about is what is involved in it, right? Let's say you have a player, right? That player is going to be the basis of object-oriented programming. Like that's going to be essentially what you focus on. I don't care what the player is doing. I don't care if the player has a step on an enemy. I don't care about that yet. All I care is that there's a player and I'm going to focus on that. And the player has, for example, an XY position, and that's going to be called an attribute. This is called an attribute. And the attribute is essentially something that it does, right? So for example, the player can move, and that means it changes its X and Y attribute. It can, it can do a lot. It can, let's say enemies, right? So let's say it hits it has a, I don't know, what else has it had? Yeah, it has a gun, right? So that's going to be connected to it, right? So that's going to be some object that it has, right? So that's going to be something that's connected to it. But let's say it has something else. Let's say it has a gender. I don't know. Let's say you get to pick your gender of your character. That's going to be, another attribute. And your attribute, you can also have functions inside of here. But the functions, like let's remember I said, it has a gun that can shoot. That's going to be connected to your character, right? That's not going to be something that you get to, write a function for. That's going to be connected because everything is connected to your player, right? So we're going to see how we can initialize something and use that player to our advantage. Use what we need to do, what's involved instead of what we need to do. Right, that we're going to learn how to take that to an advantage. So essentially, that's the main gist of everything, right? So that's called object-oriented programming. It's focusing on what you need to do. That was probably a long intro, but it was required because you might not understand everything. The code is actually very short. It is less than, I guess, 100 lines. It's pretty short, But we're going to go through that as well. Let me just share another screen. I have way too many tabs. So you're going to see like a lot of those tabs. All right. Okay. Let's go to our Space Invaders new with absolutely nothing on it. This is just a blank file.
There's only 2 tabs.
Oh yeah, no. I opened a new thing. Don't worry about it. All right. So let's start by making.
Increase the font.
Oh yeah, sure. Settings. How do I increase the font? I'm very smart. Font size.
On
large.
the very left. There's.
Is it like this? Do you want to make it huge?
Do you see the gear icon?
Yeah. Do I make it huge? I
think large.
Large should be good.
All right. Cool.
There's also a theme option as well.
Yeah, you might want to change that to dark theme.
Oh
Just
my
saying.
God, no.
I think Jerry is a strong proponent of light themes.
Fine,
Oh,
Jake,
no.
fine. Okay,
Kick
so
him off the executive.
okay, so let's see what we need to do first, right? So I'm going to walk through all the code with you, and then we're just going to run the entire thing. And then I'm going to also then explain the code. But I'm just going to start coding now, and we're going to learn everything. Now, one thing some people do is that they start like running the code before it's even done. I mean, you can kind of do that, but it's better to understand the code completely without even running it. So like while you're running it, you have a complete picture of what's going on, and it's much easier to debug. Right? Because if you're like, okay, let me do this and then try it, like it's really hard to do it. So usually I already have an idea of what I want to do in my head, right? An object-oriented programming can help you really do that. I'm going to show you how. Let's start with what we need at the start. So this is just an initialization. You don't have to do this. I like to do this. And then we're going to do game. Yeah, I'm going to tell you what this means. Let's initialize the window. I think that's a window size. Think it is? Yeah, it is. Okay. So what is this? You might be really confused about what this is. So first of all, this file is called main.py. This is a really, really good thing that a lot of intermediate Python programmers use to initialize a program. So what this means is that if the name of the program is main, right? So if this is the main file, usually you call it the main file. So make sure to call the file main.py. There's no other files. We're not making any other files, so feel free to close this package lock. Don't worry about that. But if name equals to main, then we're going to create a game, right? So we're going to call a variable called game, and we're going to make that equal to some game, right? And what this is that this is an object. So we're creating an object. We're creating an object called game, and it's from the class game. So the class is kind of like what we're trying to accomplish. We're trying to make a game, so we want to make a class called game, which lets you initialize a game. And once you initialize the game, you're able to play it. So again, what do we do? So if the name is equal to main, which means that if this is the right file that we're trying to run, we're going to create an object that is equal to the game that we're trying to make. We're going to pass it some parameters, right? This is the window size. You can change it if you want. Don't make it too big because 600 times 400 is already this big. Don't make it any bigger. And then that's going to be the game that we're going to run, and then it's just going to run the game, right? So it's pretty simple. This part is pretty simple. Now you might be thinking, is this all of the code? And this is definitely not all of the code, but we're going to continue. If I can tell my computer to stop glitching. All right. So again, we had to import Pygame, obviously, and you can. Why did that autocorrect? All right. Then we're going to make a comment. I'm joking. Let's call it Space Invaders. Space Invaders. All right. Let's start. So we're gonna make a class called game, and that's gonna be the first thing we do, right? We're gonna make a class called game, and what this game does is that this is going to be everything that runs in it. This is going to be the game that we're going to use, right? So first thing we're gonna do is that we're going to initialize a screen. Okay, screen equals to none. Because what this means is that this is an attribute of the game. The game needs a screen to run, so we set the screen to nothing, right? Because when you make a game, you don't know how big the screen's gonna be, so just don't worry about that. We're also gonna do something called alien. This is for later. This is not important at all. I can even delete this if you want. This is just not important right now. I can even comment it out. I just want to add it there because I'm gonna use it later and explain it. Don't worry about that for now. And then we have what is called this. So def init, and then we're gonna give it a self, give it a width, and give it a height. What does this mean? This means that we're initializing. This means that the first time we're making this game, right? Because this means we're making a game. The first time we make a game, we need to be given two parameters, a width and a height. The width is going to be 400, right? And the height is going to be 600. Never mind. I'm extremely smart. As you can see, I definitely didn't mess up the X and Y values. But yeah, that's going to be the initialization of the game. And then what we do is that we're going to do pygame.init. We're going to initialize the pygame. We're going to do self.width equals width, and then self.height equals the height, right? This first line initializes pygame because Why am I initializing it here? I could even, okay, you know what? We're gonna initialize it here. And the reason we're doing that is because we want to initialize the window. Yeah, this will work soon. All right. Python initialize basically initializes everything, and we want to do this here and not here. We can do this. We can do this. Like we can do this too, but the reason we don't do this is because we need to do it whenever we create a game. We don't need to do it when we start the program because no game has been created. But when we create the game, we need to first create Pygame so we can start running the screen, and we set the width and height to its corresponding values, and we create a screen that's none. Now in here, what you're gonna think, what do you think? We're gonna set the screen, right? Yep, that's what exactly we're gonna do. So we're gonna do self.screen. If you don't know what self means, self is just the object itself. So self.width is the object's width, self.screen is the object's screen, right? So for example, this game has a width, height, and screen. We're gonna set that equal to pygame.display, set mode, right? So set mode. What this does is that it sets the screen to display, and what we're gonna do is that we're gonna give it a tuple of width and height, right? So that's essentially the screen object. And then we're going to do self.clock, right? We did this previously in the tic-tac-toe, and here again because we need to know how fast, how long the code has been going for. And we say pygame.time.clock, and then we're going to do done equals to false. This is important because this is going to be used in our main game loop. Don't worry about this yet. This is going to be used in main game loop. I might delete this later, but this is not important for now. What is the clock? Let me go back to the screen thing. This is actually called a tuple. So it initializes the screen and it sets a mode. If you want to do this, you can actually hover over this and it tells you exactly what you need. You need an optional tuple int. So that's why I'm giving two ints, a width and a height. If you still don't know what this does after hovering over it, for example, clock, you're tracking the time, you still don't know it, you can do this. Pygame.display.set mode, right? I have no idea what this means, so let me just search it up, right? And then you'll see this immediately in the Pygame set mode. You'll see this immediately in the screen, and then you can read it, right? So there are many different ways you can understand how something works, right? The Pygame documentation is great, Replit is great, and even if you don't, you can try to understand it yourself. And if you don't, you can ask for help. But essentially, that's how you approach something, right? That's how you approach making a class and initializing Pygame. This all seems pretty standard for now. I just want to explain it for those of you that might be confused, because it is kind of a new concept, right? Like initializing, an object and giving it attributes is something a lot of people haven't done. So I just wanted to explain that. So now what we're going to do is that we're going to put in the initializer a game loop. So what that means is that this thing is going to run forever. So a lot of times you create a game, right? And usually you create the game, right? And then you kind of run like a def game loop, right? And then you do like a while true, and then you do print, infinite loop, right? And then you do something. But this is not actually, there's actually another much smarter way to do it, and it's that just put it in your object, right? That's why we have, object-oriented programming, because now you can put in the initialize. Whenever the game is initialized, it's going to run forever. So the game is just never going to get past the initialization, which is exactly what you want. So whenever the game is created, it's going to start looping. So how do we loop? While not true. So we're going to call this game loop, so you know what this is. We're going to make a space, while not true. And then this is going to be, I'm going to call this the game loop. This means that while you're just while not done. Oops, no, while not, it's not while not true, it's while not done, because at the start done is false, and then we're gonna wait until done is true, right? And what are we gonna do? So first of all, we're going to find when we need to stop, right? So how do we do that? Well, for event in pygame.event.get. What does that do? What does that do? Well, that takes every single event that's happening right now. So you're saying, what is going on in Pygame? What is going on here? And what you're going to say is that if event.type equals to pygame.quit, right? So if you're quitting everything, that should not have happened. What are you going to do then? What are you going to do if I quit the game? Well, I'm going to say done equals to true. What does that do? Well, if done equals to true, then this, and the next time I go to the game loop, it's going to be done. What's happening? Then the object's going to be finished. It's going to finish initializing, and bam, it's just going to, nothing's going to happen, right? It's just going to be done. you're done the game. So nothing's gonna happen left. You don't need anything to happen. You don't need the game to disappear. You don't need it to quit. You just stop everything, right? I only need to do work if there's work to be done. If there's no work to be done, you're done the game. Good job, right? And after this is just something you can put here, but add some. This is something we might do for fun if we want to, but this is kind of like an addition to the game if you want to. This is actually really cool because with games you can add stuff, right? So what might you add? Well, maybe you could add, I don't know, a win screen or a repeat screen, right? Repeat input, right? So you could put stuff here, after the game is over, right? So like, actually no, what am I saying? It's not a win screen yet. It's just a end screen, right? So maybe you can put some sort of end screen or repeat input, ask them if they want to play again. Just do something to keep their interest up, and that's something you can add, right? Even to a game that's really, really well done, you can still add a lot of things to it, right? You can still add a lot of cool, shenanigans, right? And then the next thing we're gonna do is that if, right, so now we're gonna do is that when we're done everything, we're gonna do pygame.display.flip, pygame.display.flip, self.clock.tick 60 FPS, and then we're going to do self.screen. I'm gonna explain this again. Fill.screen.fill 0 0 0, and then that's it, right? So that's essentially what we have, right? So what that basically does is that we, set the screen, right? So after we're done everything, we're going to, display the screen and then tick the clock and then update everything else, right? So that's essentially what's going to be done there. And let me just add one more thing. Actually, you know what? Are there any questions up to now? I can take a few questions. Oh yeah, you don't need to call it self. You can give it any valid name. What is pygame.quit? Pygame.quit is when you end the game. So whenever you want to end the game, you just write pygame.quit. Yeah, it's an X button on the window, or it's whenever you want to end the game, you just click that button. And it basically ends the game for you. I don't know. There's not too much to it. It literally ends the game. So yeah. And also, I think this should be indented. I'm pretty sure I'm right. Recommend putting it screen after clicking X. Yeah, you could though. You could. What I'm saying is that you could not do done equal to true, right? You could put another screen, because what you can do is that you can ask them if they want to go back. So but then this would say like maybe not, maybe comment out done equals to true or something like that, right? But I'm just saying you can add something to the end of this if you want. Let me run this. If you run this, I don't know exactly if it'll work. Hopefully it does. It should create a new window. Yeah, it does. See, it creates a new window of size 600 times 400. Don't worry about these arrows. These arrows mean nothing. But essentially, that's your screen. And now we're going to start doing a lot of stuff on this screen. And we're going to do a lot of this stuff at once. The first thing we're going to do, actually, and also fill 0 0 0 is black. Fill screen to black. You need to know RGBs for Pygame. It's just really, really important. All right, let's keep going. So then we're going to make a class called alien. This is going to be our first class. I can do this now. What is that I created in my game? I'm going to create a new thing called aliens. Right. So alien is going to be the class that does stuff, right? So that's going to be the class that displays the enemies. What does the enemies do? So def init. I'm not going to explain this a second time. We're just going to keep coding. If you have any questions, feel free to ask. All right. So what are we going to do here is that we're going to have self.x equals to x. We have self.y equals to y. Self.y equals to y. And then we have self.game equals to game. What is going on? Self.game equals to game. And so what we need to the attributes we need to pass over are that we need an x, y, and game value, right? That's what we need from our game class. And this basically lets us do stuff with the alien class, because before we need to communicate between classes. Before we're communicating between functions, now because it's object-oriented programming, we need to communicate between objects, obviously. Next, I'm going to do def draw. Now you might be confused. What are you doing? What are you doing? Why are you putting a function, right? Didn't you say this was object-oriented programming? Well, yes, but you can still put functions inside objects. It's just that these functions only exist to fulfill these objects' need, right? So like if you have a person and you have def fire the bullet, that fire is only going to work for that person, right? It's not like before, for example, if you had add, the add works for everything. It's like a global function. This isn't really that. This is more, this person needs me to do stuff, I'm going to do that. And then I'm going to do a very long string of text, which is pygame.draw.rect. What this does is that it draws a rectangle. This is obvious. Self.game.screen. So what this does is that, again, this might look, foreign, but what this means is that I don't like this. So you go to the game screen, right? So you take the self, right, which is yourself, and you're going to go to .game. So you're going to take the game, you're going to take the screen, right? Because we have the game object already. So we're going to take the game object screen, and then we're going to blit something onto it. We're going to blit it 81. We're going to blit, first of all, we're going to blit a set of a color, right? So 43, 88. Right, so that's what we're going to blit. We're going to blit a certain color onto it. That's going to be our color. And then what we also need to blit is that what are we blitting though? What are we putting onto the screen? Well, we're putting a pygame.rect, right? Obviously, because we're drawing a rectangle, so obviously we're making a rectangle. Okay, and here's my undefined name self. As you can see, I'm incredibly smart and I definitely know what I'm doing. Yeah, okay. So you need to pass self in because it's really annoying, but you need to pass it in. All right, so what does this do? This basically, if I can open a new window, how does Pygame draw a rectangle? It's actually surprisingly simple. All it does is that it takes, a starting xy coordinate and it puts the x plus 30, right? And this is going to be plus 30. Let's say that this is not a rectangle. Let's just say this. And then you're going to blit it as x, y, 30, 20, right? And that's what happens, right? So you're going to take the starting x value and then you're going to take a length and a width. And that's how you initialize that in Pygame. Okay, let's go back. Okay, check for questions again. You can actually use a tuple for the rect. Yeah, you can use a tuple, but the Pygame.rect is better. Well, I mean, I wouldn't say it's better. It's not even better. It's just easier for me to understand because, for people who are less experienced, when you see Pygame.rect, you're drawing a rect. If you just make a tuple, I mean, it works, but then you kind of forget what you're doing at a certain point. And then self.y plus equal to 0.05. What is that? What does this mean? Why are we increasing the y value? Well, remember that the blocks are moving down, right? So at every point, we're actually drawing a new rectangle. At first point, it's here, and then we put it down a bit, and then down, all the way until it reaches the bottom of the screen. And that's what we're doing. We're drawing different rectangles at each point. And because the frames run fast enough, we can update it at every point, right? And then we have alien equals to alien. All right. Oh yeah. Also, we have this. So now we're done the alien class. So we're going to test it out with drawing an alien. Test it out with an alien. So self 30, 30, right? Let's just draw a random alien and then alien.draw. Okay. So now we're going to draw the alien. And if we see, we're going to name.self is not defined. Right. I'm incredibly smart. Okay. Wait, give me a second. So basically, we're going to create an alien. Should I put this in the middle? I think I should put this in the middle of the class. All right, whatever. All right, it's fine. We're just going to do the next one. Yeah, all right. So what is the next one? So the next thing we're going to do is that we're going to start creating the other class, right? So we're going to start creating another class, right? Don't worry about if the alien doesn't exist. We're gonna worry about that later, right? I think we're kind of low. I guess we're not that low on time, but I want to get through the rest of this. So the other thing we have is a class called hero. If you want to see, you just have to initialize an alien. Don't worry about it. All right. So what we're going to do is we're going to create a hero. So what we're going to do is that def again init self game xy, and then what we're going to do is that self.x equals to x, self.y equals to y, and then self.game equals the game. What we're gonna do now is that we're gonna do def draw again. Same thing, right? We're drawing the hero, and this all follows the exact same format as before. Pygame.draw.rect. Same thing. We're gonna draw a rectangle on the screen. So self.game.screen. Into the exact same thing. See, as you can see, if you do the first one, the second one becomes almost easy. I wouldn't say easy for most people, but I mean, it's kind of repetitive, right? Like once you do the first one, you immediately know what to do for the second one because it's the same kind of thing, except you're just drawing them to different parts. And this is, by the way, very close to white, but not exactly white, so it looks cool. And then self.x, self.y, 8, 5, and just to spite Martin, I'm gonna put pygame.rect. And yeah, again, this doesn't work because Pygame is smart. I think this is right. Whatever. Yeah, it's right. All right. That was PyFlex being stupid. All right. Once we do that, we're going to now finish that. That's the hero and the alien class. We're done. We don't have any more to do for the class. That's gonna be displayed to the screen now. Do not refresh the page, please. Please do not refresh the page. All right. What else we have? Now we have the next class, and the next class is going to be, we're going to make this smaller for now. We don't really need this. The next one is going to be the class generator. You might be confused. You're like, what the hell is generator? What is generator? This is confusing me. Stop confusing me. Well, generator is basically what happens, that it generates everything, right? So it generates everything to essentially to the screen. And
Will
it's
it
very
generate ugly aliens and make them ugly?
It might. Oh, all right. The reason we're not doing different images here is that Pygame is Replit doesn't support a lot of things. So the one thing it doesn't really support is high definition images. Another thing it doesn't support is sound, because it works on VC11, which doesn't support sound, and it sucks. So we're not going to use, multiple images. We could, but it's just going to look blurry and annoying. And plus, I think the more important thing is drawing rectangles. I think you can definitely change this really easily by just blitting a different object onto the screen. But yeah, you can actually do this, right? Whoever spoke up. If you want to, you can actually change this line and change it to your whatever alien you want to make, no matter how cool that looks, or opposite of that.
How ugly?
Yeah, whatever. Yeah, whatever you want to make your alien, you can put that and just change this line if you want to. You can even do that
Can I
this
give
time.
it tentacles?
Yeah, sure. You can do whatever you
Or
want with it.
maybe a laser gun?
Yep.
Or
Anything you want. Okay.
like a
Init.
a
So then we're
tank?
going to do the same thing, which is, def init for the generator. We're going to do a self and then game. Right. And then what we're going to do here is that we're going to set some stuff, right? We're going to set some things because the generator is going to generate everything, but we also want the generator to work properly. So we're going to set a margin to 30. And we're going to talk about what the margin does later. But what the margin does is that it essentially sets the game object, the things a certain apart, and then same thing with width equals to 50. This is actually more the height. I don't know why I called it margin and width. Now that I think about it, it's more the height. For x in range, margin, game width. I'm going to explain this all. By the way, this is going to take a bit more explaining, so I'm going to just finish the code first and then explain it. Just keep coding. Don't worry, if you can't follow along, I'm gonna give you all the code, and I'm even gonna show you a cooler version of it, or not a cooler version of it, just a different version of it, I guess, if there's time. Okay. I'm going to explain all of this. Give me earn second.
1 second? How many seconds?
All right. So
Earn?
what this does is that basically this fills the screen with aliens, right? And I'm trying to draw a picture here, but it's not cooperating. I think I can draw an alien. Okay. So let me show you what I'm doing here. It's gonna take 2 seconds
Make
to
it
draw.
ugly.
So essentially what we're doing here is that we're drawing aliens around the screen, right? Let's say we draw an alien here and here and here and here and here and here and here. We want to put the aliens a certain number apart, and they should be the same distance apart. So let's say this is the next line, right? each alien should be a certain margin. And what I mean by margin is that there's going to be a certain width. So this is going to be the, there's a width and there's a margin. So this is the width.
Wait, I have a question.
Yeah.
If the generator generates aliens and the purpose of the game is to get rid of all the aliens, then shouldn't we get rid of the generator
True.
so that we win the game?
True. If you got rid of the generator, you win the game. But like the point of us is not to play the game and win the game. The point of us is to make the game, right? So we want other people to play the game and not just,
So-
you know, destroy the generator. All
So
right,
if you're a player, in order to win, you hack into the coding
you
and
could.
then
You
remove
could.
that.
But we're not talking about that yet. We're talking about this, which is how to create the aliens on the screen. We can talk about some other stuff, but you know, this is creating margins and stuff. All right. So the margin is going to be the distance between these, right? And the width is going to be the distance between these, and these should be the same, right? The between the aliens should each one be the same. Mine is not the same because I am very good at art, as you can tell. But you can, you know, draw this better if you want. But essentially, this is the plan, right? We generate each alien, and notice that we're generating aliens. So each of these aliens is a separate object. Each of these is a separate object. Before, when we do functions, each of these is nothing. Each of these things means absolutely nothing. It is just a rectangle that we draw to the screen. But now it's not because each alien has a specific property and it's important to us. It's no longer just something we draw to the screen and forget about, right? As you can see, each alien, we draw an alien to it. And how do we do that? Essentially, we have, you know, for X in range, margin. So for X in range, we have a margin, gain width minus margin and width, right? So we're gonna loop the X margins. We're gonna loop the Y margins, which are the widths. So we're gonna loop every X and loop every Y. So we're gonna loop X and we're gonna loop Y. We're gonna draw an alien to the screen. So it's gonna draw this one, 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 this one. Now you might say, isn't that slow because each of these is an object? It's slower, but it's still really, really fast because this is Pygame we're talking about, right? This isn't, you know, your computer that runs on Windows Vista. This is very, very fast. Yes, aliens equal to generator. Yes. Yeah, this is Pygame we're talking about. It's much faster than you might think.
Also, well, I have a question. What if your character has a tinfoil hat, so it'll repel all of them?
You could make that. You could add that into your game.
Yeah, so you'd win by default.
Yeah.
Microtransaction.
Yeah.
So
Oh,
you can make money off it. Create
exactly.
a tinfoil hat.
Oh, Martin. Yeah, it depends on how you use the list because it's a list. You have a game.aliens.append, right? We talked about we have an alien. We talked about we have an alien is here, and it just appends directly to the list, and you append an alien to it, right? And that's essentially what it does. Oh, you're questioning my design. I mean, if you want to, you can make a much better version of it if you want, or or a different version of it if you want. But this is the version we're working with. I know there are definitely flaws with, you know, everybody's design, but I guess that's more of an everybody thing, right? Because, you know, if you want to find flaws in design, there's flaws in everything, right? If you look at like the best games like Half-Life 2, there's so many bugs in that. It's become a meme, right? So, you know, even the best games have bugs in it. You can obviously, you know, critique the design flaws, but it should be that your game, you know, if you want to make a successful game, just make a game that works, right? If it works well and, you know, you understand what you're doing, that's, you know, the thing that's most important about it. Exactly. But Half-Life 2 is 100. Yeah, I know, but this doesn't have as much bugs as Half-Life 2. Yeah, they're features. Thank you, Eddie. But yeah, that's essentially how, you know, just make a game that works. That's the most important part. All right. Design flaws happen naturally. Just let them happen and debug them. Right. So now we're going to make a class called Rocket. And the Rocket is going to be the bullet, but we want to call it Rocket because we are PG friendly. In it, we're not going to call it a rocket. We're going to call it a shooting
Wait, what's
device.
the PG-13 version? You said that PG version is Rocket.
No, the family friendly version is Rocket. So you know, we want
what's the non-family friendly one?
We don't need to mention that here, right? It's the friendly channel.
Rocket?
It's for our YouTube channel, so this needs to be family friendly. All right, let's keep going. So self.game, and then same thing. This is the exact same thing. By this point, you should already, you know what we're doing. I definitely didn't spell that wrong. But by this point, you should know what we're doing, right? Def draw self pygame.draw.rect, self.game.screen. And then we're going to draw 254, 52, 110, right? We're just going to draw more things to the screen. This is just blitzing everything, right? But this is the same thing, right? As you can see, everything is just drawing something to the screen. 1, 2, 1, the other ones are the same. If you even want to make your own game, you can do this. Just draw something to the screen. It's very simple. I'm not rect, x, self.y, 2, 4. And in the last few minutes, we're finally going to put it all together and kind of do the most important part, the most important part of the game. Now that you know how the rocket works, right? The rocket is just a bullet. It's a much smaller one. As you can see, the player in the rocket should be smaller than the aliens because you want the aliens to look scary and intimidating. The next thing we want to do is that before we move on to the biggest chunk of the code is to kind of do some collision detection. This is the main, I think, the main part or the most important part of our lesson, which is how to check collisions. I'm going to code and show you as we go along. Check collisions. Okay, self and then game for rocket in game.rockets. If rocket.x less than self.x plus self.size. Okay, this is a long one. I'm going to explain this. I'm just going to write this. And rocket.x greater than self.x minus self.size. I'm going to explain all this. This is just going to take a while. Just follow along and code along. If you don't want to code it, I have a final version for you. Don't worry about it. Rocket.y less than self.y plus self.size. And rocket, finally, rocket.y greater than self.y minus self.size. Now you might be confused. This looks confusing. I'm scared. Don't worry, this isn't scary at all. This shouldn't be intimidating for you if you understand how this works. So game.rockets.remove. These two lines are easy. You should already know what they do. This removes the rocket and this removes the bullet. Not the rocket, the rocket. Alien.remove self. So, right, we're going to talk about all this. We're going to start with this. This is the most important part. Right? How do we check collision between two rectangles? This is where CP comes into handy. You might think that CP is not useful and not applicable in real life, but it is. It's really useful. It's really useful. And if you understand the logic, see, this is literally an algorithm. This is literally what CP is used for. It's an algorithm. We're using these algorithms to solve it, right? Before we learned about, different, demoj and demoj algorithm, we're now using them in our game dev, right? Everything is connected. Even two things that you think have no correlation are connected in some way, right? So how do we check for collisions? Well, this is kind of like the same problem. I think this was a problem that came up somewhere. Maybe Ryan can confirm. But essentially, you want to check collision between two rectangles, or if two rectangles are intersecting. And this is exactly what was tested once on either a CCC or some other DMOPC. But this is literally an algorithm problem, right? Because what we do is that we find the collision between the two, and we check if that exists. The algorithm itself is not very complicated. Yeah, Martin, exactly. Young, that is a very good question, and I can even really quickly mention if you even want to, but it's a lot harder, but it's almost the same idea. Basically, what you do is that this is actually again another question, which was Young. This was actually a question on difference array on a circle. If you remember that question, which was a CCO question, finding remember you had multiple circles and you were trying to find the intersection between them. This is also applicable in pennies in the ring, kind of like that. But when you're with a circle, there's a special way that we do it, where we kind of check for collision differently than we check for this, right? But essentially, we can kind of interpolate it and imagine it kind of as a square, and then kind of like for the two problems that I mentioned before. There are ways, to interpolate the circle like this and then check for collision, using polar coordinates or some other form. there are many different ways. Yeah, I don't want to get in too much into calculus, but tangents, you can try using polar coordinates to find it. You can try to find area. You can interpolate it into a square. You can do a lot of things with it. But essentially, this is a CP, right? That's a CP algorithm that you're asking about. So it's insane how these two things are connected. But this is our much easier problem about how two rectangles, right? How two rectangles can collide together. And the way we do this is very simple, right? We check if this value is greater than this value. Watch what happens if they don't intersect. Do you notice that this value is greater than this value? So if this value is less than this, doesn't that mean that they definitely intersect, right? So this means that they intersect this way, but we're not done, right? Because they can do this. These two don't intersect either because this one is less than this one. So we notice is that if all four of these intersect, so like if this one intersects these two, right? This is less than that. If this one is less than this, if this one is less than this, so like we kind of interpolate, right? So if this right side is less, if this left side is less than this right side, and if this right side is less than this left, then this left side greater than this right side, right? We're going to have a collision. And the same thing with this one, right? This one is the same thing. So these two collision and these two collision. So we're going to check, if these two, collide with each other. And that's how we check for collision. We check if the x values of the rectangle have some overlap, and if the y values of the rectangle have some overlap. This is easy. If you know coordinate compression, this is very simple to what we're doing. If you know, if you know integrals, this is also kind of related to that. But essentially, we're trying to prove that the area beneath it exists, and that's a CP concept. And how we do this is that we check for the x values, and we see if that's less than the set dot size. And we're going to see if these values are, proportional to each other, and if they're less than their corresponding sizes, right? So if rocket.x, so the left of the rocket is greater than the size, like it's to the left of it, and it's also the right side is less than that right side, then it's going to intersect on the x side, and then we check if it intersects on the y side. So if the area exists, area between rectangles exists, we're going to remove the rocket from the game, and we're going to remove the alien from the game. Notice that we remove the rocket itself because we take in the rocket and we remove it. We don't remove self because self is the alien. We remove this. We do remove self. We don't remove self here. We don't do this, right? Because the rocket is something that is inherited, right? Okay. Let me see if there's any questions with CP concepts or anything like that. Yeah, exactly right. This question, wireless. That's how you would do it, Young, which is really cool. Anyhow, that's my rant on CP and its importance in even game dev. But that was a really cool thing, right? And now with our, probably 5 minutes, but we might go over like a few 2 or 3 minutes, but that's fine. We're just going to talk about the final thing we need to do, and then that's going to be the end of our game, right? So the final thing we need to do is we need to put everything together. We have all our classes. We have everything that we need to make the game possible. We have our class, we have our objects, we have, we have the draws, we have the functions, we have the attributes. Now we just need to put everything together, right? So first of all, the first thing I want to do, I'm going to add some things. Now that we know we need to do more. So obviously we need a rockets, right? Obviously, we also need a loss equals to false because we need to know if we lose the game. And we lose the game when the aliens go beneath the screen. That's when we lose the game. All right. And then now what we're going to do is that we're going to add a few more things. We're going to add a few more things. First of all, we're going to check a few things. So if the length of self.aliens is equal to 0, what that means is that if there are no more aliens, we're going to self.display text victory achieved. Yay, that means we finished it. Pressed, and then what we're going to do a key press. So press equals pygame.key.getPressed. And what that means is that we're checking if any key is pressed. This is very simple. So if there's a key press, it's gonna display here. So if pressed, and we're gonna see which key is pressed. What if pygame.k left? What if the left key is pressed? What do we do? Well, we're gonna hero.x minus equal to 2 because we're moving the hero left, right? So if the left key is pressed, we're gonna move the hero left, right? What about the right key is pressed? So if pressed pygame.k right hero.x plus equal to 2 if here. All right, we also had to add a boundary, right? So the boundary here is that if hero.x is less than 20, else 0. What that means is that if the hero's x is greater than or equal to 20, then we can keep moving it. If it's not, then don't move it anymore. And don't move it too much. Right? If hero.x less than width minus 20, else 0. Right? That's just a boundary check. If you don't understand that, feel free to ask in the chat. Otherwise, that's just a boundary check to whatever we want to do. Next, we have elif. This is also elif, because obviously we don't want both buttons to be pressed and the thing to just implode on itself. And then for event in pygame.event.get, if it's quit equals to true, so event type, and then we have if event.type equals to pygame.keyDown, right? So then what we need to do is that we're going to check another thing. We're going to check if the space bar is pressed, right? So event.key equals to pygame.k space and not self.lost. That means that we haven't lost the game yet. If we click the space bar and we haven't lost the game, we should fire a bullet. How do we fire? Well, self.rocket.append rocket self hero.x hero.y. Why does this work? This looks insane. How does this work? Well, it works because the rocket is getting shot from the game. It's getting shot from the player and it's getting shot up. And once you create that rocket is going to auto update every turn. And that's the most important part of object-oriented programming. Once we create the rocket, it's going to work by itself like magic, and it's just going to update itself every time and start moving up. That's why we want class and objects. Once we make the class, once we initialize that class, we don't need to care about the object itself. It will work. Yeah, it shouldn't work. But in any case, if both left and right keys are pressed, it should just move in whatever. It should usually move to the left or the right, because usually this doesn't happen. So I mean, you technically don't want to use elif if you don't want to, but I mean, it's really a programming. It's just a design thing. If you like moving to left, then if you like it moving to one side, then do it. Otherwise, just don't do anything. So then it just won't do anything. And then the next thing we're going to do is that once we're done every event, we're going to do pygame.display.flip, which everything we've already done before. And then the final few lines, I think 2 lines in for aliens in self.alien. So we're going to loop through every alien. If you haven't seen this, it's a for in loop, which means we're looping every single alien in self.aliens, and aliens is not going to be a variable. Considering some alien.draw. See, this is what we talked about. This function is not used by everybody. It's used by the alien. Everybody has a draw, but the alien draw is different from the player draw. This is important, right? Because the alien draw is what is important, because the alien is draw, not the player, right? This is used for the object. It is not used as a function. We are thinking objects, not functions, right? We're thinking not functionally. And that's the important part of why we do these things, because now we can think about how everything works together. And I'll do a quick recap at the end, 2-minute recap at the end. So alien dot check collision self. Check the collisions if there's a collision with anybody else. And what happens if there is? If alien dot y is greater than height, right? Yeah, again, we check the collision. If there's a collision, we remove it. If alien.y is greater than height, we're going to do self.lost equals to true. We're also going to display self.display text. You died. And what does that mean? That means if the y is greater than height, that means if they reach the bottom of the screen, you tell them that you lost the game, and then display the text that you died. Right. That's essentially what we're doing. Okay. And oh, bruh. Wait, why does it need? Okay, it's gonna work somehow. Okay, and then we finally have the next one, which is for rockets in. Let me see if there are any more questions. or whatever. 4 rockets. If it gets rid of the error, it gets rid of the error. 4 rockets in self.rockets, rocket.draw. This should be commented left. I don't know what I'm doing. No, okay. I do know what I'm doing. I am just inting. All right. If not, self.lost, hero.draw. I'm gonna draw the hero. It's not lost. And then, that's gonna be essentially most of the game. I'm gonna look through if there's anything else. Def init, as you can see. Wait, where is this? This would be line 81. I probably forgot the def init. Yeah. Def init, forgot the self. Game X, Y. Okay, let's run this again. Okay. All right. This is going to take 2 minutes, and I'm just going to explain everything. Okay, attribute error. Game object has no attribute. Display text. All right, yeah. Oops. So I need to add a display text function, which I think I have. Oh, right, yeah, I don't have a display text function. So here I'm just going to add a display text function. Graph display text. We have a self, we have a text. All right, and then we have 4 rocket in self.rockets, rocket.draw. And then, no, what am I doing? Display text. Oops, wrong. What am I doing? All right, pygame.font dot init. Because I was thinking, I was like, I was supposed to draw the rockets, but then I supposed to do display text. All right, font equals the pygame.font. So we're gonna create a font that's called Arial. Now we're gonna make this 50 font. We're almost done. Just 1 more minute. Text.
Use Comic Sans. Use
Sure.
Comic
Render.
Sans.
Sure. Font
Wait,
render text.
Carry on line 38.
Wait, which one?
Line 38.
Yeah.
Should be alien.y, right?
Yeah. Oops. I'm incredibly smart, as you can see. As you can see, I'm very smart. Okay. Clause 44. Yeah, I'm not too worried about debugging. That can happen after. I just didn't have a part of my code written. That's the thing I'm worried about. The actual, debugging is more or less easy. That's green. Split. I just need to make sure I have the code written. Hex surface. 110, 160. And what this does, that this basically lets you, let's switch to the screen. Right. One more thing. All right. So I'm going to quickly debug this and then give you a recap of everything. Just hang tight. Give you a recap of everything. I'm going to delete some of these comments, actually. Yep, okay. Oh yeah, okay. Give me a second. All right. Okay. I deleted some of these comments. Should work now. It should run. Yeah, it runs. It just tray slow. Give me a second. Okay, let's just run this again. Okay. Right, run this. Right. And that's it. That's the game. We can do, then we can play it. So we can move left and then shoot bullets, right? And then we can play, right? So as you can see, everything works, right? So we have the different classes. We have everything that goes down, right? The aliens that move down along the screen. We have all the players, right? We have a player shooting bullets, right? The bullets move, the bullets start moving at the bottom and they start going all the way to the top. And then, the bullets actually, they don't move up, but like they do this. So that's cool enough. And then, they do this. And then once you're done, you see the button. See, as you can see, you can't see this because it is in dark mode, SMH Albert. But it says victory achieved. Actually, you can't see this either way. Let me just, I can make this a different color. If I can. Yeah, exactly. Okay. So that's going to be it. That's our game, right? So what we learned is that, first of all, we learned object-oriented programming, right? Which is what we do to create, start creating our game, right? So we didn't focus on functional programming, which is what we did before, right? Focus on everything as a function. We focused instead on object-oriented programming, right? So where everything is a certain function. I'm very smart. I changed that to 0, 0, 0. As you can see, I'm very smart.
How would you make it harder? Like increase the speed?
Yeah, so first of all, you would increase the speed. I can even do that now. So you would increase the speed. I don't even know. Oh, where's the speed again? Yeah, so alien, you would increase it by plus 0.2. And now if you run it, it's going to go a lot faster. As you can see, look at this. Well, this is really, really hard to play now. And then, you just shoot all the aliens. And I missed that, so I'm probably going to lose. Right, and then you have to shoot them before you go to the end of the screen, and you see victory achieved. And that's the game. Pretty cool, right? And that's going to be the game. If you want to make it even harder, you can add different things to the game. I'm going to change it back to 0.1 just to make it a bit easier. And then if you also want to add stuff to the game, so extra ideas, you can add a restart option or more types of enemies. Right? You can maybe add an enemy that moves left and right. You can add an enemy that goes zigzag. You can add so many different types of things. You can even add a restart option, right? Remember what I said before? But you can add something once a game finishes. Right? We can add many different things to the game.
What about a teleporting alien?
You could.
Or like an alien that shoots?
Very questionable object-oriented programming. I mean, it is. It looks kind of questionable, but it also is, right? Because it's a lot of concepts. It's a concept of object-oriented programming that's important. And we did this in literally less than 100 lines. If I can make this lesson, I can make this in under 100 lines. So this is a really cool game that we can make in not too much code, in mostly a lesson. And it's a really cool game as well because we can learn the concepts of object-oriented programming and how we can think about a problem and how to really tackle a problem, right? If we want to make a game, how do we make it? How do we create a working game that also is structured to our capacity, right? So this is a really, really great way to understand game concepts. I will definitely share the code. I will share that right now. Give me a second.
Yeah, and kind of what Jerry was talking about regarding the object-oriented stuff, especially if you were in Intro to Python. Although I think you could also get through CP without knowing object-oriented programming too. So I think like this stuff with classes might be like really new for a lot of you guys.
Yep.
But it's also really important, and it's good to start learning.
Right.
So don't be like angry if like
Yeah.
if it seems a little confusing.
Really quick, let me just share the code. Okay, give me a second.
OOP is a very game-specific concept. I'm just gonna say that.
It is. It's pretty.
It's not seen like in many other places.
Yeah.
Actually, should I even? Actually, you know what? I'll share the code, but I'll also share something else.
Yeah.
So if you want the code right now and you want a downloadable version and a printable version, I'm gonna share a file with you right now. So from your computer, and then documents, space, invaders, code.txt, open. I think that's it. Yeah, it worked. Did you guys get it? Does the code work? Okay. And the other thing I wanted to share is this is the GitHub repo that I worked on everything with. It's been forked a few times as well. But here, I'll just share the code that we worked on today. This is the repo for the code that we worked on. I feel like it's better. This is the code that I wrote a long time ago. So I think Albert forked it, but it's pretty cool as well. So if you want to, this is the starting code of what I did a few before, and this is completely non-edited. This was not something we did together, but it's the exact same game. It's just not as well formatted, but you can also, the good thing about this is that you can fork it and kind of make your own game from this. So yeah, I'm going to share the link to that as well in the chat. So if you want to take a look at that, you can take a look at that as well. So though both of these things will be posted as well on the Discord as, and also on the classroom as material. So if you want to look at this and go through this yourself, do some stuff, fork it or add some stuff to it. Or if you have any questions and you want to ask me, feel free to DM me or any of the other execs, or just ask in the channels. And yeah, that's essentially the game we made. So if you have any questions, you can stick around. Otherwise, thanks for coming.